An object from interstellar space has been observed to visit our solar system. Neil deGrasse Tyson says that Oumuamua has suddenly returned and it's not alone. Oumuamua is the name of the mysterious flying object that whipped past our solar system years ago, but the way it traveled puzzled scientists for years, almost like it was not natural. Scientists believe it was a rock while some say it was gas. This thing came in moving fast, yes, that has escaped velocity, a hyperbolic orbit. But there are a few that genuinely believe that it was an alien spaceship. So join us as we uncover the mystery of Oumuamua and find out if it really was a scout from another civilization. What is Oumuamua? Back in October 2017, something extraordinary happened in our solar system. The University of Hawaii's Pan-STARRS 1 telescope made an incredible discovery. It spotted the first interstellar object known to visit our solar system, named Oumuamua. Located atop Maui's Haleakala volcano, the Pan-STARRS 1 telescope is exceptional when it comes to spotting space rocks, even faint ones like Oumuamua. The official name for it was 1I, 2017 U1. However, the Pan-STARRS team gave it a more poetic name, Oumuamua, translating from Hawaiian to mean, a messenger from afar arriving first. Oumuamua looked like a reddish cigar-shaped object made up of rock. Its elongated shape is striking, stretching up to a quarter-mile long and about 10 times longer than it is wide. Oumuamua has an aspect ratio that surpasses any asteroid or comet observed in our own solar system. Its elongated shape is quite surprising and unlike anything we've seen before. This unique characteristic might provide valuable insights into the formation of other solar systems. But how do we even know that this object came from outside the solar system and not just some rogue Kuiper belt object? Neil deGrasse Tyson says that it's extremely easy to find out. It's all thanks to the speed of the object. We can tell an object is extraterrestrial if it's going very fast, too fast for it to be contained by the sun's gravity. Oumuamua was traveling at a speed of 196,000 miles per hour when it got close to Earth. That is 109 times faster than a bullet, meaning there was no way this object was part of our solar system this whole time. Scientists could not tell if Oumuamua was an asteroid or a comet, but what's the difference? Comets are made of ice while asteroids are rocky. Scientists first thought it was a comet, then changed their minds to call it an asteroid once it zoomed past the Sun on September 9, 2017. They still considered it an asteroid until additional measurements indicated slight acceleration, which is a sign of it being a comet. But the fact that Oumuamua accelerated much more than we predicted was what confused scientists for years. Bizarre trajectory. When Oumuamua made its appearance, telescopes worldwide eagerly observed it, aiming to gather as much information as possible during its brief visit. They made intriguing discoveries: the absence of visible dust or a comet tail, an unusual elongated shape 10 times longer than it is wide, and a reddish color resembling objects found in the outer regions of our solar system. Observations even found the age of this object. Oumuamua had been wandering alone through the cosmos of our Milky Way galaxy for hundreds of millions of years before coming to visit. As Oumuamua departed our solar system, it accelerated faster than expected, surpassing the influence of gravity alone. This acceleration resembled the boost that comets experience as they move away from the Sun. When a comet's ice evaporates due to solar heat, it propels the now lighter object forward. But the speed boost and trajectory of Oumuamua did not follow the predictions scientists had made. The peculiar trajectory of Oumuamua raises questions. Why did it follow such an odd path through space? Since its discovery in 2017, scientists have put forward various theories to explain the object's nature, formation, and high velocity of approximately 196,000 miles per hour. One hypothesis suggests that Oumuamua could be composed of solid hydrogen, which transforms into gas as it approaches a star, pushing the object forward. In this scenario, the entire object itself would act like a natural ion engine. Some scientists proposed the idea that the cigar-shaped object might actually have a more disc-like appearance. They base this notion on the way it accelerated away from the Sun during its passage. But many planetary scientists argue that its behavior could resemble that of a comet, a phenomenon commonly observed in our solar system. Another potential explanation for this acceleration not accounted for by gravity is radiation pressure, which is the force exerted by sunlight on an object. However, for sunlight to have such an effect, the object's density would need to be extremely low. The unique shape and exceptionally low density of the objects sparked lively discussions within the scientific community about its possible origins. Some people even entertain the intriguing possibility of the rock being an alien light sail, crafted by an intelligent extraterrestrial civilization. While one scientist firmly believed that this pancake-shaped object was an alien spacecraft, such claims were met with skepticism, as with any scientific hypothesis involving intelligent aliens. There likely exists a more plausible explanation. But even so, let's take a look at how substantial this argument was. Intelligent alien life. Oumuamua, the first confirmed object from outside our solar system, presents one peculiar characteristic: its shape. While it is often depicted as a cigar-shaped body in artist renderings, there is a possibility that it is actually more disc-like. Since we could only observe it from specific angles as it traveled through our solar system, meaning its specific proportions were largely unobserved. In October 2018, Dr. Shmuel Bialy and Professor Avi Loeb put forward a theory that asked if solar radiation pressure could be the key to Oumuamua's odd acceleration. Their study underwent peer review and was accepted for publication in the astrophysical journal Letters, but it sparked a mixed response based on several lines of evidence. The duo suggested that Oumuamua's unusual characteristics could be explained by its pancake-like shape and highly reflective nature, resembling a light sail. Its sudden acceleration and deviation from the expected orbit aligned with the effect of radiation pressure interacting with a light sail. And even the way in which it entered our solar system resembled that of an interstellar explorer. It flew by Earth after its closest approach to the Sun. Its orbital dynamics provided it with a close encounter with the only habitable planet in our solar system, resembling what one might expect from an interstellar probe. Naturally, this claim stirred controversy. Some media outlets sensationalized the theory, suggesting that Professor Loeb and his colleague were proposing an alien origin for Oumuamua. On the other hand, there were those who dismissed the idea, wondering why a reputable scientist like Professor Loeb would even entertain something they deemed unscientific. Despite facing opposition, Professor Loeb not only stood by his argument but also went on to publish a book delving into his controversial theory and the journey that led him to it. In his book, Loeb takes a more personal and impassioned approach, appealing to both the scientific community and the general public to genuinely consider the idea that Oumuamua could be an extraterrestrial messenger. So is Oumuamua a space probe made by an intelligent species? Let's take a look at Professor Loeb's book. After spending years presenting this contentious theory to the scientific and astronomical community, Professor Loeb shared the story behind his idea in this book. The book delves into the mystery surrounding Oumuamua and, most significantly, encourages readers to seriously consider the possibility of an extraterrestrial encounter. Professor Loeb described his arguments in more detail in his book, Arguments he made back in 2018. As Oumuamua prepared to depart the solar system, the Hubble Space Telescope captured final images that revealed an increase in its velocity. The most straightforward explanation for this phenomenon was that Oumuamua was releasing material from its surface due to solar heating, a process known as outgassing, which aligns with the characteristics of a comet. However, as Bialy and Loeb emphasized, there should have been unmistakable evidence of such activity. One confusing aspect of Oumuamua was its lack of a tail when it made its closest approach to the Sun. Furthermore, the sudden acceleration it experienced couldn't be explained by gravitational forces. If anything, gravity should have been causing it to slow down. Additionally, if Oumuamua had been outgassing, it would have resulted in a rapid change in its spin, but no such violent spin was observed. According to Loeb and Bialy, the most plausible cause for the increase in velocity was radiation pressure. However, if Oumuamua wasn't a comet or an asteroid, then what could it possibly be? Moreover, what could explain all of its peculiar behavior? The only thing scientists were certain of was that Oumuamua was unlike any object ever observed before. All attempts to explain the weirdness of Oumuamua in terms of nature were paper-thin when the book was written. There was no single explanation that could account for its brightness, shape, and acceleration while also acknowledging the absence of outgassing. This idea was partly sparked by Professor Loeb's involvement in Project Starshot, a program aiming to develop a spacecraft capable of reaching the Alpha Centauri system within our lifetime. After careful consideration, they realized that using a light sail propelled by a 100 gigawatt laser was the most effective approach to achieve speeds close to the speed of light. They also concluded that the spacecraft could be as small and light as a mobile phone. Thus, the concept of Starshot, combining a light sail and a Starship spacecraft, took shape. When Oumuamua arrived, it coincided with the fresh memory of Starshot in Loeb's mind, and everything started to come together. Only after they checked and confirmed the calculations did the theory of an interstellar probe truly take form. The next step was to determine the size, composition, thickness, and reflectivity of such a probe. In the end, all the evidence aligned and pointed to one key notion: Oumuamua was not of natural origin. According to Loeb, the hypothesis of a light sail may appear unconventional, but the logical path he and Beerley followed did not involve any far-fetched assumptions. They carefully analyzed the evidence and adhered to a scientific principle similar to Sherlock Holmes's detective work. It stated that when you have eliminated the impossible, whatever remains must be the truth, even if it seems highly unlikely. Based on this, they put forth the hypothesis that Oumuamua was an artificial object. Loeb effectively presents his case for a potential interstellar light sail by examining the limited evidence available on Oumuamua. While we can never definitively confirm whether Oumuamua was an interstellar probe or not, it might be worth keeping an open mind about this possibility. Neil deGrasse Tyson's take. Neil deGrasse Tyson had much to say about Loeb's theory. Neil has known Loeb for many years and considers him a brilliant and contemplative individual. Loeb ventured into the realm of the search for extraterrestrial intelligence and expressed concerns that this topic should receive more attention and funding. Many scientists want more funding, but the question is how to justify it. The argument proposing Oumuamua as an alien spacecraft did not convince the majority of Loeb's colleagues, but it resonated with him, which led him to write a book that captured public interest. Neil wants there to be alien life too. He's equally excited about the possibility, but he cautions against assuming aliens as the immediate explanation for unexplained phenomena. Loeb conducted significant research before reaching his conclusion, but there may have been additional research avenues that he overlooked due to lack of awareness. Neil said that Loeb didn't do all of his homework before presenting his theory, but to be fair, we didn't know enough back then anyway. In an interview with Star Talk, Neil discusses the peculiar nature of not having a clear understanding of how Oumuamua's trajectory was affected during its passage near the Sun. He notes that if an object is moving in a manner not dictated by gravity, there must be another force influencing it. He says that there are other explanations for it, like the possibility of ice content melting off as Oumuamua approached the Sun, but he says that he's not going to jump to conclusions and say that it's aliens. While he doesn't completely dismiss the idea, he prefers not to immediately suggest extraterrestrial origins as the primary explanation. But if not aliens, what else caused Oumuamua's odd trajectory? Hydrogen iceberg theory. In early 2020, researchers proposed a fascinating idea about Oumuamua. They suggested that it could be a hydrogen iceberg. The origins and molecular structure of the object could be explained by this theory. The concept was that pure hydrogen gas would act like a propellant, pushing Oumuamua forward like a rocket. While the hydrogen iceberg theory seemed intriguing initially, further analysis suggests that it faces challenges in terms of survivability and formation processes. A paper authored by researchers from Harvard and the Korea Astronomy and Space Science Institute cast doubt on the viability of this theory. A few researchers, including Professor Avi Loeb, expressed skepticism about the theory. There were various issues with the theory of a hydrogen iceberg. One significant problem was that an iceberg of this nature couldn't be formed through the usual processes that result in the creation of solid objects. The usual process involved in creating solid objects like Oumuamua, such as sticky dust colliding and gradually accumulating, would not be applicable to a hydrogen iceberg. In order to form a hydrogen iceberg the size of a kilometer, tiny grains of hydrogen would have to collide with one another and stick together. Then this process would be repeated with larger and larger grains through sticky collisions. But the higher the density of the gas, the more heat is generated per collision, causing any solid hydrogen to be instantly turned into gas. So a hydrogen iceberg the size of a kilometer wouldn't be able to form because the grains wouldn't be able to grow anymore. In essence, the researchers argued that the usual process of grain growth through sticky collisions is hindered by the presence of high gas density. Additionally, such an object wouldn't have been able to survive the long journey that Oumuamua undertook. Hydrogen icebergs would evaporate too quickly during the journey, which could last hundreds of millions of years. If the hydrogen ice theory were true, it would have been a groundbreaking discovery, shedding light on the cigar-like shape of Oumuamua and its non-gravitational acceleration during its journey. But scientists still had more theories up their sleeves. Dust bunny theory. In September 2020, an intriguing theory emerged, proposing that the elongated space rock might be similar to a giant dust bunny. Dust bunnies are those clumps of dust and debris that gather under furniture due to static electricity. Scientists think that Oumuamua could be thought of as a scaled-up version of a dust bunny. Oumuamua might have come from a comet located outside our solar system. According to this study, the dust composing Oumuamua was blown off the comet's nucleus, gradually accumulating to form the peculiar rock. The solar radiation then propelled this rock through space, eventually leading it on a brief tour within our solar system. The original comet from which Oumuamua originated was likely a long-period comet. These comets take a considerable amount of time to complete their orbits around stars, often venturing far away from them due to the comet's weak gravitational pull and the pressure exerted by radiation. Oumuamua separated from its parent comet, embarking on a trajectory into interstellar space until it briefly passed through our solar system. While this theory seems convincing, scientists moved on to better ones in the future. Nitrogen iceberg. After an extensive 4-year investigation and the exploration of various theories, the astronomical community seemingly arrived at an explanation that accounted for all the observations. 2 studies published in March 2021 proposed a compelling case suggesting that the interstellar visitor could be a sizable fragment of nitrogen ice that broke off from a distant solar system's Pluto-like exoplanet millions of years ago during its formation. This nitrogen iceberg theory serves as a natural explanation for Oumuamua's behavior, following previous research that suggested it could be a rocky fragment from a planet torn apart by its star. These findings are a far cry from the extraterrestrial speculations that arose when Oumuamua was initially detected. Although initial skepticism was present among some researchers, the nitrogen iceberg theory aligns with many essential criteria. Even astronomers who weren't involved in the study, like Scott Shepard, acknowledged its plausibility, saying that it could indeed be a fragment of an icy dwarf planet. But the case wasn't closed yet. In their study, the researchers analyzed the behavior of various types of ice composed of hydrogen, nitrogen, and oxygen under similar circumstances. Surprisingly, it was discovered that a substantial chunk of nitrogen ice would exhibit the same characteristics as Oumuamua. Unfortunately, measuring nitrogen gas proved challenging for astronomers using the available telescopes at the time. The studies say that there was indeed a tail-like feature present in Oumuamua, similar to what we would expect from a comet, but we didn't detect it because of Oumuamua's nitrogen composition. The studies also identified potential sources of nitrogen icebergs. Planetary bodies such as dwarf planets and celestial objects located at the periphery of solar systems, including Pluto and Neptune's moon Triton, are known to possess nitrogen ice on their surfaces. Based on the findings presented in the 2 papers, the authors proposed that during the early stages of a distant solar system's formation, collisions between planetary bodies occurred, resulting in the detachment of a nitrogen chunk. Over time, this nitrogen iceberg made its way to our corner of the Milky Way. As it approached the Sun, its surfaces eroded, ultimately transforming it into a flattened pancake-like shape. The concept put forth by the researchers was highly compelling and successfully aligned with the observations made at the time. Even other astronomers found the idea convincing and commended its ability to explain the available data. But this theory wasn't airtight. An opposing argument was presented in a study done by Professor Avi Loeb and Amir Siraj. According to their paper, the fact that we detected Oumuamua implies that there are a whole bunch of them in our galaxy. But if we assume that objects like Oumuamua are formed entirely of nitrogen split from exoplutos, then there must be a lot of exoplutos to account for this. But the number of exoplutos in our galaxy is calculated to be extremely low. So either Oumuamua isn't really made entirely out of nitrogen, or we were completely wrong about the number of exoplutos in our galaxy. The researchers checked to see whether there is a sufficient amount of material in the Milky Way galaxy to support the formation of such a population of nitrogen icebergs. The only way so many exoplutos could exist in the Milky Way is if the stars they formed around had enough leftover material to create them in the first place.